Okay, now our third logarithm rule is going to be the quotient rule. The quotient rule means that when you are dividing, you're going to do something about this log to simplify this or expand this. And that is log base b of x over y can be expanded as log base b of x minus log b of y. So when you are dividing, we are subtracting. This is what we did in exponent rule as well. So when you had, say, 2 to the x power divide by 2 to the y power, when you are dividing, what we did is 2 to the x minus y. So if you think about this, like log base and then the argument represents the exponent. Since we're subtracting the exponent, it only makes sense if you are dividing the argument, you are supposed to subtract these two because they are representing exponents. So log base b of x minus log base b of y is going to be our quotient rule. So if you are using this rule to expand this example, log base 4 of 4 over 6, I can rewrite this as two separate log expression, log base 4 and then log base 4, but these arguments are going to be 4, very good, minus, and the log base 4 of 6. All right, so again, one important thing is you have to keep that order. 4 has to be the numerator has to be the first one that it comes, and the denominator goes to the second one, and the log base 4, the base hasn't changed, and it has to be subtraction when you see the quotient or fraction form. Okay, so let's do number 31. Expand log 5 of 11 over 3. So if you do this, if you expand this, again, using the quotient rule, we're going to separate them into two different log expression. But do I change the base? No, we don't. We don't change the base. So this has to be log base 5, log base 5. And what should be the argument? The number goes in here. Yes, so it's going to be 11, and then minus log base 5, and then the argument has to be 3. Very good, and that is it. That is it. It's not that difficult, is it? All right, now number 34. Number 34 is log base 3 and 7a over 2. Okay, so just like the other questions, we're going to separate them, and it's going to be log 3 and 7a, very good, minus log 3 and 2, very good. But I can challenge you, I will challenge you to do more, one more step. Since 7a is 7 times a, can I apply another rule on this one? All right, so log base 3 and 7 times a, what kind of rule is that? Yes, that's actually is going to be our product rule. So if you are applying the product rule in here, you can break this down one more time as log base 3 of 7. And since it's multiplication, what should I put in the middle? Is it plus or minus? It's multiplication. So it's going to plus, very good, log base 3 and a. And then the rest has to be the same. So I'm just going to write down the same thing, which was minus log base 3 of 2. Yeah, the handwriting is crappy, but thanks for bearing with me. And yeah, that should be my final answer. Okay, so let's go over number 4, change of the base. Change of a base rule. That actually is going to be important in terms of using calculator. So let me erase this part. And let's move on. So when you look at change of a base rule, this might be confusing, but let's take a look. So log base of a of x. This can be rewritten as log base b of x divided by log base b of a. So what has happened is the argument x became the argument of the numerator, and the base became the argument of denominator. And they created another base, and that can be anything. But like I said earlier, when you're using calculator, the base 10 is always the default setting. So we're going to change it into log base of 10 so that we can easily use calculator to evaluate the logarithm expression. So here's the example. So log base 4 of 5. Okay, so using this change of a base rule, what you can do is change it into log base, whatever the base is, and then 5, which was from here, and log whichever that base is. You can put this 4 as the argument. But remember, I said that you can choose the base, but like I said, we're going to usually use 10. We're going to assume that the base is going to be 10 so that we can easily use the calculator like this. So when you put this in a calculator, all you have to do is hit log and then 5 and then divide by log 4. Log and then 4. So let's try with the calculator to figure out what that estimated value is. We don't normally use this equal sign. We're going to like curvy equal sign like this, meaning that this means estimated. It's not exact value, but it's estimated, and it's close to 1.16. So I need you to use calculator to figure out the rest questions, and I believe that's all you need to know for this assignment. So again, if you still have a question, if you still don't get any of the parts, please reach out to me through email or your phone call, text, anything is fine. So please reach out to me, and I hope you've enjoy the rest of your day.